All right, welcome back. Today, or maybe later tonight, we're talking about covalent bonding. We previously talked about ionic bonding, and now we're going to cover covalent bonding, what it is, how to do it, all that good stuff. So first off, what is it?
Well, good question. We are bonding a nonmetal to a nonmetal. Now, if you recall, last time we were talking about ionic bonds, and that was between a metal and a nonmetal. So now we have two nonmetals bonded together.
Okay, so we're looking at opposite sides of the periodic table. So if you're looking at your own periodic table, if you colored them yellow like the textbook, they're same color.
Yes.
And the same color.
Yes. Here's a good example of a covalent bond where we have water here, H2O, and you can see in a covalent bond what we're going to be doing is we're going to be sharing electrons, which is a little bit different than the ionic bonding. Ionic bonding, we were transferring electrons.
Right. Another way to remember this, if you think they're sharing, so covalent, like they're cooperating.
Ooh.
That's one way to remember that they're going to share electrons. So electrons aren't leaving. We're just going to kind of group them together, and they're going to be sharing them between atoms.
Ooh, I like cooperating. That's a good one. Now, last time with ionic bonds, we were transferring them, so we ended up with a charge where we were creating an ion. Mm-hmm. Now we are going to form a neutral particle called a molecule.
So different ionic bonding, you form ions. Covalent bonding, you form molecules.
Absolutely. We're gonna show you one here. We're gonna do hydrogen and chlorine. You see that we have a nonmetal bonded to a nonmetal. So it's just easier if we rewrite this, so that way it's easier to get our electrons arranged around how they need to be shown. We're using a dot diagram again, the electron dot diagram, and we need to look at our periodic table. So that way we see how many valence electrons there are in those elements.
So hydrogen is in above group number 1, so it gets only one dot, has one valence electron.
Right, and I'm going to use a dot and an X to represent the different electrons. I'm going to use a dot for hydrogen here, and that's one valence electron.
Chlorine, on the other hand, is in group 17, so it gets 7 valence electrons.
Awesome. So I'm going to use an X just to show this.
That way you kind of remember which electron belongs to which atom. Since they're sharing, we don't have the arrow showing they're moving anywhere. They're staying put. If you use X's and dots, then you can tell which electron belongs to which atom.
Right, and for this hydrogen, we want to make sure that we put that dot, that one valence electron, right next to chlorine, so that way it can be shared. So now what you'll see is chlorine, by sharing with hydrogen, it has its complete 8 that it needs.
Again, wants to fill up all of its valence electrons, or each atom is trying to get to 8. Or we do have our little exception here, though.
That's right. Hydrogen is a small atom. It is only completing the first energy level, and that only needs 2. So you can see by sharing with chlorine, it gets the 2 it needs to be complete.
So this covalent bonding, it's actually a shorter process. You start off just like we did with ionic bonding, where you draw your electron dot diagrams, and now all you have to do then is draw circles showing how each atom now has a full valence electron set. So chlorine with the circle now has 8 electrons in that set. So your circle includes the atomic symbol, chemical symbol, plus all 8 for chlorine.
Yes.
Hydrogen, on the other hand, being a small atom, only needs 2. So our circle here shows it has the chemical symbol for hydrogen and 2 electrons in that circle.
Very good. Yep, and you can see that right there. Moving on, here's another one. We will learn how to name these. This is nitrogen fluoride. But what we would like you to do right now is we'd like you to practice this. So at this time, why don't you pause us and then practice this on your own and see if you can show us how the nitrogen with the 3 fluorines are covalently bonded together.
As just a hint, since there are 3 fluorines and 1 nitrogen, put the 1 nitrogen in the middle. Put the 3 fluorines around.
Here, I'll show them before. Yep, let's get them set up before they pause. So on 3 sides of, whoops, my pen. It's my pen, not me.
It's of course not her handwriting. It's the pen.
Yes, here's your setup. Now officially pause us and try this. All right.
We're
Well,
back from our official pause.
that's right. Welcome back. Hopefully you had the opportunity to do this and you were correct, but we'll double check to make sure. Nitrogen. Nitrogen, if you look at the periodic table, is in group 15, which means it has 5 valence electrons. So I'm going to put our 5 electrons around here.
Notice she's putting the unpaired electrons nearest to the fluorines because that's where the sharing is going to happen. Nitrogen already had its own set of paired electrons, so we just stuck those down on the bottom.
Absolutely. Now fluorine, if you look at fluorine on the periodic table, it is in group 17, which means it has 7 valence electrons. So what I'm going to do is I'm just going to use dots to represent the electrons in fluorine, and we're going to get the 7 around here. And of course, the sharing pair will be right here next to the nitrogen and the fluorine.
I always want to set it up, kind of make it easier on yourself so you can make nice, easy circles.
Absolutely. Now, yep, now we should be good where we can see that each fluorine has the 8 it needs to be complete. And then nitrogen here in the middle has the 8 it needs on each
So
side.
when you're counting electrons in it, it doesn't matter that it's dots and X's. What matters is that we get up to number 8.
That's
or,
right.
of course, in hydrogen's case, up to 2.
Exactly. All right, good job with that. Let's try one more.
Let's try another one.
Let's try another one. We'll get you set up, and then you can pause this and try this. So now we've got chlorine with 4 chlorines to 1 carbon.
Okay, so that's how you're going to set it up. Pause it now, try this on your own, and unpause it when you're ready to go.
Great. All right, welcome back again. Let's do this to make sure that you were correct. So should we start with carbon in the middle?
Carbon in the middle.
Okay,
Yep.
go ahead, Mrs. Tolk.
You know what? I like writing dots is
Okay.
a lot easier. So let's put X's on the carbon because we're
Okay.
going to put a lot more dots on
That's
them.
true. That's
so
true.
carbon is in group 14, so that means it has 4 valence electrons. And 4 valence electrons, we're going to put them one on each side, just like we set up with the chlorines around it.
Yes.
Each chlorine now is in group 17, so each chlorine has 7 valence electrons. So we're going to put, again, the unmatched up electron nearest to the carbon, and then the other 5 get arranged around the side. Excuse me, the other 7 get arranged around the side.
Yes, and I have to apologize. My drawing isn't very neat this time. I'm feeling a little.
Your pen isn't working as well.
That's right. It has to be the pen.
If-
I'm feeling a little spaced out here, but I think we can still show
And
what
we
I
don't
want to
make
show.
any blonde comments at all
Hey
about
now.
that.
Hey now. Hey now. Hey now. Okay, now by sharing.
There we go. Chlorine got 1 or sharing 1 with carbon, so chlorine is now full with 8 electrons. Top chlorine, now full with 8 electrons. Chlorine off the side, full now with 8 electrons, and the chlorine to the bottom as well. Carbon in the middle.
Ooh,
It's
look at
kind of
this.
hard to find in there,
Yep.
but there it is. It's going to share 1 electron from each of those chlorines.
Yep, 1 and 2, 3 and
There
4,
we go.
5 and 6, 7 and 8.
All 8 in there. Okay,
Great.
So we're not going to see any of the chlorines sharing with each other in this case. Each chlorine is sharing just with the carbon.
Right.
All right.
Right. Great. Good job, guys. Now, there are some unique ones here. On occasion, we may see a double bond.
Right, so they're going to share 2 pairs. All the ones we've been showing you so far, they're sharing just 1 pair of electrons
Right.
apiece. Sometimes they're sharing 2 sets of electrons.
So I'm going to get this one set up, and we'll kind of go over this with you guys. We've got carbon. This is carbon dioxide.
Again, put the singleton in there in the middle. Put the oxygens on either
Yes.
side.
Yeah. Okay, so we have carbon. Carbon is in group 14, so it has 4 valence electrons, and I have to make sure that they're sharing with my oxygen, so I have to put them on this side, these 2 sides of carbon. Oxygen, and this is going to be where it's a little weird. Oxygen has 6. It's in group 16. Now, we're going to do this. We're going to put 2 on the top and 2 on the bottom. Now, we're so used to going over here and putting 2 dots, but we don't want to do that for this case, because if we did that, you can see I'm going to just kind of draw a little light line around here. that is going to give oxygen with 8, but look at how many carbon would have there.
Right. We have to put those electrons where carbon can share too, not just oxygen.
Yeah.
So we have to kind of keep carbon in mind. Carbon needs to share with oxygen as well as oxygen shares
Right.
with carbon.
I'm going to rewrite this so it's a little bit neater so you can see it. So we've got our 4 carbons, and now we're going to get our 6 oxygen electrons around. We need to put it right here. And we'll show you here in a minute why that is. So now oxygen over here has the 6 it needs. So now this is a little bit different. We've got 2 pairs in the middle.
That's why we call it a double bond, because you have 2 pairs of electrons there. So really you're looking at 4 electrons total, 2 different pairs.
That's right. So now if you look at oxygen now by double bonding it has the 8 it needs.
Same with this oxygen.
Same as this oxygen over here. Now carbon in the middle
There it goes.
has the 1, 2, 3, 4, 5, 6, 7, 8
So the end
it
result
needs.
is still that they both have 8. And you can also kind of tell this if you forget and you set this up, you know, putting an X on each side of carbon or putting your dots on the other side of oxygen.
Yep.
When you go to make your circles, like why don't you try to make a circle for carbon? Go ahead and finish that top one out. Let's say
Okay.
you had it drawn.
If I did it
incorrectly.
like this incorrectly,
Yeah.
okay, so we'll just kind of draw it wrong.
So because the oxygens are going to look fine.
Yeah.
You're going to make your circle for oxygen, looks fine. Make the other circle for oxygen, piece of cake, and then you get to carbon, and suddenly now, what happened? Either you've got 4 there, or so we only have 4, or you try to stretch your circle, and your circle is trying to stretch over the top of the oxygen. If your circle starts to look like a boot, or a sock, or an
Gotcha,
elephant,
yes.
that is bad.
Yes, we don't want to be stretching around like,
Yeah, nothing
like
crazy
this.
Like that.
No.
That is not a circle.
no.
So that would be a clue to you saying, okay, something's funky here. I must have to do a double bond. Redraw, move your electrons along as you need to. Always do your covalent bonding in pencil. So
Yeah, good call. Okay, that was double bonds. Now there is another unique one, and that's called a triple bond.
Fun continues.
It does.
Triple the fun.
Triple the fun. So now, just like it sounds, there is now 3 of the pairs in the middle. Honestly, I think...
Should that be N2 then instead of N3 on our little screen?
Oh yeah, look at an error.
Oops.
This is the first error I've made this year.
Gosh. And we're here to witness it.
I know.
And we're recording it.
We are recording. It should be N2. Now nitrogen, if you look at nitrogen on the periodic table, it is in group 15, so it has
5 valence electrons.
5 valence electrons. And we're going to arrange these 1, 2, 3, 4, and 5. And I don't know, Mrs. Toke, but this is honestly the only one I give them that's a triple bond. So if they know how to do...
One I've ever given you.
Okay, if they know how to do this one, they're in good shape. And they probably know by now that this N2,
What is that an example of?
that's a diatomic molecule.
Diatomic.
Diatomic. Di meaning two atoms.
There you go, diatomic. 2 atoms. So 2 atoms of the same element.
Yes.
There's 7 on the periodic table. You should know those 7, the big 7.
Yep. All right.
And there's the 5 for the other nitrogen.
So now when you do this, and it looks really,
Look at that.
really weird, you've got your 3 in the middle, adding those up, 1, 2, 3, 4, 5, 6, 7, 8. You've got 8
So they've got 8, so they're happy. They got a full
They
outer
do.
electron shell.
through a triple bond.
And again, N2 is the only one that we're going to have you be
Yes.
responsible for knowing that one.
Yep. Awesome. All right, you guys been a good audience again today. Thank you.
Keep practicing. See you in class.